So, and this thing is being supported by CMRSC, so which is Creative Minds Royal Concept. Okay, so today we are going to be talking about a lot of topics inside mathematics, but the simplest one we'll be talking about first is indices logarithm. So, I don't know. We are going to be very fast with everything we want to do because we actually have a lot to cover. So a lot to cover. So first one, we are going to be talking about indices and logarithm. So indices and logarithm, and then we have a laws that actually guide it. So we have a laws of indices, we have a laws of inside logarithm actually also. So, but let's firstly talk about, let's see what is happening under indices. So indices is actually a way you can simplify. Like now inside your physics syllabus, which actually be the first, I think is the first topic now, inside your mathematics syllabus as an engineering student. So we are just going to consider those laws, and also after the law, then we are going to solve some one or two examples, then we can move from there. So the first rule of indices now, rule of indices. So we have the first one. The first one is when you have the same base. When you have the same base, which is multiply, if there is multiplication between them, and you have another one which is raised to power n. That is, you have the same base that have different power. So this is what we call power, and this is what we call base. So whenever we have something like this, it's actually equal to, we taking the base, any of those base, then we take it as A. Then if is multiplication that is between them, what will be between those power, if you combine them, will actually be addition. So I'm going to say this is m plus n. So that is the first rule inside indices. So we have another one also. We can have something like a raised to power m, which is divided by a raised to power n. So this is simply, if there is a division that is between them, actually is going to be subtraction that will be between the power. So if I combine these now, that will be a raised to power m minus n. All right, so now if you have something like this, what this is actually telling us is that we can actually use these rules that we have here to simplify, like to simplify a lot of things that we want to simplify. So you might be given a very complex simplification to do. Maybe you might have x raised to power 3, x raised to power. So this is what you are going to be using to simplify them. All right, now let's take some example. Maybe take, for example, we have something like simplify. All right, so simplify. Maybe I have like x raised to power 3, y raised to power 4, and z raised to power 5. So maybe divided by 6 now, multiply by 9. Here we now have x raised to power minus 2. Then we have y raised to power minus, let's put minus 3 here. Then over z raised to power 2. So let's take, for instance, you have to simplify something like this now. If you want to simplify something like this, we need to actually apply the rules that we have here. That is the laws of indices that we have here. So how can we go about this now? So we can see that there are some that have the same base. I told us earlier that anything that is here is actually what we mean by base, and the one that is being raised to power is what we call power. So if I want to simplify this, it will actually be, this is of the same base. So we are going to combine them together, so they will come together and say x raised to power 3. So now this is multiplied by, this is x raised to power minus 2. So multiply by x raised to power minus 2. So this is y raised to power 4, multiply by y raised to power minus 3. So we have y raised to power 4, multiply by we can put multiply. So it's also multiplication here. Multiply by y raised to power minus 3. So now, if we have something like this now, we have already combined what we have at the numerator. So remains z raised to power 5. So we can easily put our z raised to power 5 also here. So everything divided by, let's combine what we have in the denominator also. So we have 6 here, that is 6 raised to power z raised to power 2. So if I have something like this now, it's going to be s raised to power 3 multiplied by s raised to power minus 2. So far they have the same base here. So, and there is multiplication between them. The rule says that what will be between this power will actually be addition. So if I combine this, I'm going to have x raised to power, this is 3. 3 plus minus 2, that will be 3 minus 2, that is 1. So now multiply by, so this is y raised to power 4 multiplied by y raised to power minus 3. All right. So now if I have y raised to power 4 multiplied by y raised to power minus 3, if I combine these two, so far they have the same base, then, and the multiplication is the one between them. So our combinations of their power will actually be addition. So if I combine their power too, I'm going to have y raised to power, this is 4 minus 3, so that will be 1 also. Then I have z raised to power 5 is here, and z raised to power 2 is here also. So I can easily take this one to the numerator. If I take it to the numerator, what am I going to have? I'm going to have z raised to power 5, then everything over 6, the 6 that is here. Then I can take this one to the numerator. So if I take it to the numerator, it will surely carry power like that. So it's going to be minus 2. So if it's minus 2, my final simplification will simply be x raised to power 1, which is simply x, y raised to power 1, which is simply y. Then I have z multiplied by z raised to power minus 2. So that will simply be 5 minus 2 also, that will be 3. Then I will have z raised to power 3, everything over 6. So that is our final simplification. All right now. So that is how to actually simplify indices. That's how to actually simplify indices. If you are given a very complex one also, you need to take them one by one, then you try to simplify it using these two rules. So let's quickly combine it with, let's see what do we mean by logarithm. So logarithm is actually like finding a solution to all these things. I need to rub this now. So I'm going to write some rules also that guides logarithm. Then we are going to solve some questions also, then we see how it goes. All right. So there are rules that also guide rules of logarithm now. There are rules that guide logarithm also. So, and the first one is when you have, I think we have like 4 or 5 now. So when we have like log of A, then base B. So what do you mean by this is that here also we have a number here and we have a base. So now just like the indices rule that we talked about earlier, this one also, if there is a multiplication that is between them, multiplication, or let's start from here. Let's say it's plus that is between them of log B base of log B base maybe C now. So if you want to combine this, the rule says that so far they have the same base, they can actually be log of base B, so far they have the same base. So far the addition is here. I told us under indices that if we have addition between them, so what we actually have here will actually be multiplication like that. But if it's multiplication that is between them, what will actually be between them will actually be plus. So I'm going to say this is AC. So this is so far there is equal to sign that is between them. Of course, it's also equals to each other. That is, if you want to simplify log AC base B now, it also simply means that it's also log B, it's also log A base B, then plus log C base B. All right, now that is the first rule. Let's talk about the second rule also. What is the second rule? The second rule is maybe when you have your when we have our log b now, which is a, over log b, which is c, it simply means that so far there is addition between them, between these two logarithm equations, then what will actually be between them here will actually be subtractions that we talked about earlier. So this will also be log of base b, log a base b, which is minus log c base b. All right, using this now, we can also let's see all the rules that we have. So we have another rule also called a change of base theorem. What do we mean by a change of base theorem is how you can actually simplify, like how you can work with your base. You can change them from anything that you like. So now take for instance, I have like let's say I have log of a base b now. This thing is actually the same thing as me saying 1 over log of, now this is what we mean by change of base theorem. We actually want to change the base of b. We want to change it to a now. So what I'm going to have here, anytime I have 1 over log, it will just be log b base a. So this is what we mean by change of base theorem. You can see that we've actually changed the base of this logarithm. All right, now we have another change of base theorem rules that you need to familiar with, especially for JAMB standard. So now let me write the last change of base theorem. Then we are going to solve questions on this. So let's take for instance that I have something like this, which is log maybe a now base b over, or let's do it this way, log a base b. This is simply the same thing as we saying that this is log of a base, find another base. We can say base c now. So over log of b base c. So this thing is also the same thing, and this is what we also mean by change of base theorem, because of course you can see that we've totally eliminated this base b. We've totally eliminated base b, and it has now become, so this is also useful in simplifications of logarithm. So it's also useful in simplifications of logarithm. So with all of these things now, we can actually start to solve any question that we have in logarithm, any simplification we can actually do. So we are going to be solving some questions here. Let me see. We are going to be solving some questions. We just solve some little so we can move to another topic. Okay, so let's solve some questions. Let me see. Sorry, I need to rub this now. Okay. Okay, let's see. So the question says that if I have log, so we are going to apply all the logarithm rule we've been talking about so far. We are going to apply it here now. Let's say we have a log of, oh, what is happening? All right, so we can firstly do the what is it called now? The simplest one, then we move to the higher one. Let's say you are asked to find the value of x in this particular equation, and you have it to be equal to 2. So maybe you are asked to find the value of x from here now. So what will our value of x be inside this? So we want to find the value of x. So what we can actually do here is actually this, because we can see that where we have our x here is is at the base. Okay, is at the base. So this will also be log x 49, so is equal to, now there is a way we can write this 2 that is there. This is a method and a strategy if you want to be very good at solving logarithmic equation. So this is actually a typical logarithmic equations, and if you are not careful very well, you might make a mistake here. So now look at this particular question here. We have a log 49 base x and log 49 base x, which is equal to 2. So we want to find a way that we can write this 2 also in terms of x, and so in terms of base x. Now how can we write 2 in terms of base x? It's simply this. So I know that, take for instance now, I know that my log, I would have included it inside the rule in the other time. So I know that if I have a log a now, which is, they have the same base, anytime I have my logarithmic, logarithm having the same base and the same having the same base, the same thing are inside the logarithmic equations, and also the base also are the same thing. So the rule simply says that this guy is simply 1. All right, now let's take for instance, I now want to write 2 in terms of this, in terms of something like this. What I will simply do is that, so far I know that also another root that we still need to add with what if written in the other time is this, for us to be able to simplify this particular question, is this. You know that if I have my log of a, maybe raised to power x now, let's say base b. So if it's power of x that is there, and I can simply say this guy is simply by sending this power back to the log, the back of the log. So that is the rule. The rule says that you send this power that is there. So this will simply be x log a base b. So haven't we understood these two rules? Then we can easily apply those two rules here now. Now if I want to write this now, and I want to write this to have a base, in x. So what am I going to do with this is simply this. I'm going to write this 2 now to have a base x. And what I'm going to do is that I'm going to write x here now. I know that if I write log of x, base x, is simply 1. So for me to make it 2 now, I'm just going to, I can simply come back here and put 2 at the back. So let me write it very well. So I can say this is log x now. So now, if I want to write 2 now, I know this guy is simply 1, according to this rule that we wrote here. That is, anytime we have log of something that is the same, that have the same value with the base, is simply 1. So now, I know that my log x now base x is simply 1. So how can I make it 2 now? I can just put 2 at the back. So that will be 2 log what? 2 log x base x. So, and this now is simply 2. All right, so now if I want to move on from here, so I can easily say that so far I have my base here also as x. I will say log x, which is log 49 base x, is simply equal to sending these 2 to the back, because as I wrote here in the other time, I told us that if you have x log a base b, is simply the same thing as we saying carry this x to the other side, it will turn to the power of it. All right, so and it will have the same base, also the same. So now if I want to do that, the same thing here, I can send this 2 to the top. It will now go and serve as what? As power. So that will be log s2 then x. So now with this now, we've already gotten our base with the same thing, like we've gotten log is x here, and in our RHS also is also in x now. So let's now continue with this. With these 2 now, I can easily cancel each of them out because they are of the same base already. So I will now have which is equal to x squared. So if I have my 49 equal to x squared, what am I having? I can say x squared is equal to 49, the same thing. So it means that my x is simply, we can say plus or minus 7, or we can say 7. All right, so our value of x here is actually 7, square root of 49. All right, now, so this is a basic and typical logarithmic equation by applying our rule to it. All right, let's just solve some more examples, then from there we can move to another topic. I think I'm trying to look for another example. All right, I want to rub this now. So you can ask to simplify different, maybe you might be giving the question you might be giving might not have, maybe find the value of x. Of course, you might have something like simplify alone. So if I have simplifications alone, it means that I need to find my way to actually see how I can simplify it in order to get something tangible. So now if I have, like, take for instance, now you are asked to simplify something like this now, which is log of base 2, 6, minus log 2, log 15 base 2, then plus log 2, 20. So if I want to simplify this now, with the rule that I've given us earlier, so we can easily apply it here now. So we can see that this guy have the same, all of them have the same base. So if they have the same base, for us to combine them, if we want to combine them now, we can apply the logarithmic rules that I wrote for us in the other time. Okay, now this is minus between them. So if I have minus between two log and they have the same base, we can easily combine them to give us a division. That is, we can say this is simply log of base 2, then 6 over 15. So now if I have something like that, then I can say plus what? Log 2 of 20, log 20 base 2. So I can see here that what you actually have here is plus between them. So if you have plus between them, we can combine them. So far they have the same base, according to the rules that we wrote in the other time, we can say this is of base 2, then it can now be 6 over 15. So far plus is here, it will now be multiplication that will be between them. So if I have something like this now, I can move on by saying that, oh, this thing is actually log 2, then this is 6. For us to be able to simplify this, we can just say any rules you want to use, you can use your basic calculator for it, or you just combine them. 6 times 20, 6 times 20 should be around 1, 2, 6 times 2, 12, 0, 120 over 15. So, and of course, if you want to simplify, maybe you did not see your answer this way, it means that, but it's not advisable. This is how they will actually put the answer. So that is the simplification for that. Okay, so now let's just talk about another topic now. So from there, we can later take every question together, then we see how much questions we can actually solve. So now let's see. I have another topic here, but I think before we go with that, I saw one interesting questions also here too. Let's quickly do this. It should be inside the past question too. All right. So now this is also find the value of x. I have two equations here, then after that we can move on. So this is 2x minus 5 then is equal to 1. So we are still going to solve this one also. We have log of x plus 2, then plus log of x minus 2 is equal to log 60. So now let's quickly do these two equations then. From there, we can move to another topic. So the first one says that log of 2x minus 5 base 10 is equal to 1. So how can we do this? As I told us in the other time, the best way for us to do this is to convert the RHS, which is the right hand side. We are going to convert it also to have the same base as this LHS. So and how can we do that? We can do that by simply saying that this is log of 2x minus 5 base 10 is equal to, let's write this one also the same rules, with the same rules as this. So now if you want to apply this rule also to it, I can say this is simply log of 10 base 10. So if they have in logarithm, if your logarithm have the same base and the same function inside it, so it is simply return 1. So now if I have something like this now, so far we have base of 10 here and base of 10 here, they can easily cancel each other. So and what are we having now? It will now be 2x minus 5 is equal to 10 that we have here. So see, don't go and make a mistake, because some students used to make this common mistake. And the mistake is that you will think that, oh, this thing is very easy. Let me just take this one and just send it to the other side and start to. So it will actually lead to error. You need to firstly convert this one to base 10 also. So you can use it to cancel each other of the sides. So now, let's now move on. What you have here is 2x minus 5 is equal to 10. So we can easily simplify this linear equation. So this will just be 2x is equal to 10 plus 5. And this is actually 2x is equal to 15. So We have 2x is equal to 15. It means that x is equal to 15 over 2. So if I have 15 over 2, is by saying that x is simply, we can say this is simply 7.5. So we can have our answer that way. All right, let's quickly solve the second question. Then from there, we can move to the other topics that we have here. So now the question 2, I want to rub this now. The question 2 says that we have log x, log. In this scenario now, you can see that there is no base. So they did not even give us any base. So we are not given any base. So if this is the case, you assume that the base is actually base 10. So anytime you are not given a base in logarithm, it's actually base 10. They are all in base 10. So if they are all in base 10, it simply means that if I have my log, it means this is in base 10. If you like, you can write it. If you like, you cannot, you might just leave it like that. So I have my log s plus 2 base 10 plus log s minus 2 base 10 is equal to log 60 base 10. So if I have something like this now, from here we can apply our rule of logarithm that we wrote in the other time. So how can we do that is this. We can simply say that this is log of base 10. Then so far there is more addition that is between them. I told us in the other time that what will be between here will now be what? Will now be multiplication. That is s plus 2 into bracket s minus 2. So if I have something like this, which is equal to log of base 10 60. Okay, so if I have something like this, so far both of this side now is now in base 10 base 10. So we can easily cancel each other. So if I cancel each other now, this will now be s plus 2 into bracket s minus 2, then is equal to 60, because we've already cancelled the base, the logarithm that is between both of them. So if I have something like this now, I can now open it. If I open it, I'm going to get quadratic equation, which is x multiplied by x, that is s squared. This is x multiplied by minus 2x. This is 2 multiplied by x, that is plus 2x. This is 2 multiplied by minus 2, that is minus 4. So if I have minus 4, which is equal to what? Which is equal to 60. So if I have something like this now, I can say this is s squared. Then we have here minus 2s plus 2s cancel each other. Then we have minus 4 is equal to 60. So if I have this now, I can send it to the other side. That is s squared is equal to 60 plus 4. So 60 plus 4 is actually s squared is equal to 60 plus 4 is actually 64. Then we can have x is equal to square root of what? Square root of 64. And square root of 64 is plus or minus 8, right? So, which is 8. Therefore, the value of our x here is simply what? Is simply 8. But now, let me give us a very good shortcut if you are given this type of questions in your JAMB. Of course, you don't need to actually solve all these things if you are given in JAMB, because of the time and all like that. So the best thing you can actually do is this. You know, you will be given an options. There will be an options inside you can just use a trial and error method to get your this thing done without wasting your time. Let's take, for instance, maybe you are given this particular logarithmic equations and you are asked to find the value of x now. If you are asked to find the value of x and you are given maybe option A now, you are given option A 6, option B, let's say option B now is 5, let's say option C now is 4, let's just put it that way, then option D is now 8. Now, how will I pick? I can without me solving all these things, I can easily pick the answer, correct answer from here. So far, you'll be providing the options with it, okay? So now, how can I do that? I will just be picking them one by one, then put them inside this equation. Once you give me this log 60, then that's my answer. That's just it. So if I pick 6 now, if I put 6 inside this, let me show us what I'm talking about. Because, so this thing will actually save us from wasting our. So you can easily find your way around it without you. Even if you are given a very complex one, Trial and error method will actually save you out from a lot of stress now. So now, if I take my 6 here now and I substitute it here, look at something. This will be log 6. 6 plus 2, that will be 8, right? So that will be 8. Then plus log 10. If I substitute 6 minus 2, that is 4. So if you combine this guy, that is actually log of 8 times 4. What is 8 times 4? 32, right? So we have 32. Should it be 32? Yeah. So now you can see that it's not actually log 60. So it's not correct. So you pick the second options. Yeah, you test the second option also. If you test it, maybe you now get to option D now. If you insert option D inside your question, you will have log 8. 8 plus 2, that is 10, plus, if I have here, that will be log of what? Log of 8 minus 2, and that will be 6, right? So if you combine this is absolutely log what? Log 60. So without you wasting your time, you can easily pick the correct options and you will just pick it and you move on. All right, now from here, now let's move to the another topic that we have. So we want to talk about a change of base theorem now. We want to talk about a change of subject. So what do you mean by a change of subject? Change of subject is just a way for you to know how to, especially for those coming in for mathematics. Maybe you want to study pure mathematics, study engineering. You will later come across it where you will need the applications for it. All right, now what do you mean by change of subject? Change of subject now. All right, now let's take for instance you are given a particular equations, and inside that equation there is now another variable that you are asking to find to change the subject to. Let's say I give you something like y is equal to x plus 2 over let's say 3 now. I now ask you that make x the subject of the formula. So if I ask you that make x the subject of the formula, what I'm actually talking about is simply that you should make x you should all right, so what do you mean by change of base? Now they can ask you that, okay, make x the subject of the formula. Make x the subject of the formula. So what do you mean by make x the subject of the formula? It simply means that I want to make x, like now, y is actually the subject of the formula here because y is actually the only one at one side, then the other variables inside it is at this side. So the same thing goes with that. So if I want to make x the subject of the formula now, what am I going to do? You know, I have my y is equal to x plus 2 over 3. So I can easily cross multiply. If I cross multiply here now, this will simply be 3 multiplied by y. That is 3y. So it's simply equal to, you know, this is over 1. This x plus 2 multiplied by 1 also. That is x plus 2. All right, so if you have something like this now, we can easily make our x the subject of formula by easily sending this 2 to the other side. So it means that I will have 3y, sending 2 to the other side. So that is plus there. If we get here, it will be negative. So if I have negative here, I will have minus 2 here, which is equal to x. Then it means x is equal to 3y minus 2. So this is actually what we mean by change, make x the subject of formula. So we have already make x to be at one side of the equation. All right, that is a good one. So now let's see how we can actually tackle some JAMB standard equations. Now if you are given, if you are asked to make a particular, let's see some questions inside your past question, so we can use that one too. I think I saw one in the other time. All right. All right, so I'm rubbing this now. I'm rubbing this now. All right. So let's see this how we can tackle this particular question. So here they are saying that, is it make t now? Yeah, make t the subject of the formula here. So make t the subject of the formula. Make t the subject of the equation. So, and what is it? We have AV over 1 minus V. So here we have capital letter V, we have small letter v. The one at this numerator is actually small letter v. So 1 minus capital letter V. So which is equal to cube root of 2V, which is capital, plus T. Everything over, oh, we cannot see this. Okay. So is actually equal to, is this 1 minus C or what? So actually equal to A, I think maybe A minus T. Let's say minus T. It's not really clear here. Good. Now let's simplify this and see how it goes. So the first thing you need to know here is we will just try to be manipulating it for us to have our T the subject, for us to be able to make our T the subject of formula. So what are we going to do here is that we send this cube root to the other side. If you send cube root to the other side, what am I having? If it's cube root here, if you send it to the other side, it's going to give us cube. So if it's cube in the other side, in one side, if you send it to the other side, it's going to give us cube root. Same thing goes with square also. Square and square root also is the same thing. Let's say in the RHS you have it as square. If you send it to the other side, it's going to become square root. So, but if you have square root in the other side, in one side, if you send it to the other side, it's going to become square. So that is the method now. So now if we have cube roots in our RHS here, we can send it to the LHS. So if we send it here, it's going to become cube. So now let's firstly do that first, because our T is actually in this side. Okay. So I'm going to have AV over 1 minus V, all raised to power what? All raised to power cube, raised to power 3. So if I have something like this, which is equal to, here we can now have 2V plus T over A minus T. So if I have something like this now, what can I do with this? How can I simplify this further? We don't know, maybe this is actually 80. It's not really clear in the, I think it should be 80. All right. Yeah. So now if I have something like this now, from here we can cross multiply, of course. We can cross multiply. We can say this is, this will just be AV over 1 minus V, all raised to power 3. All right. So is equal to, let's cross multiply. Cross multiply will now be 80 here. So which is equal to 2V plus T. Okay. So now if I have something like this now, I can send this one to this side. So if I send this 2v to this side, what is it going to be? It's going to become let's do it this way. Let's send t to this side. So I'm going to have at into bracket av over, so that will be 1 minus what? 1 minus v all raised to power 3. So let's send t to this side. T to this side will be minus what? Minus t. Okay. So now, and that will be is equal to what? Is equal to 2v. So if you have something like this now, from here we can factorize t, because t is here, t is also what? T is also here. So that t is in this term and t is also in this term, we can easily factorize it. Let's finish it in this side. All right, let's factorize it. We can factorize t, which is into bracket. What are we having left here? We are going to have a into bracket av over 1 minus what? 1 minus v. So all raised to power what? All raised to power 3. So we've already factorized what? We've already factorized the t out of it. So, and here also, yeah, in this term also, if we factorize t out of here, we are going to have minus what? Minus 1 here. So minus 1 will be here. All right, we've done a great job. So if we equate it over what? Over is equal to 2v. All right, from here now, so far we've already factorized t out of them. We can easily make it the subject of the formula like that. So what are we having here? We can say our t will simply be 2v over what are we going to have here? A into bracket av over 1 minus v all raised to power 3, then minus 1. Okay, so that's how we can make anything the subject of formula. It's just for you to follow it step by step, then you are good to go. You are good to go with it. Okay, so now from there, now we can now talk about, let's talk about polynomial also a little bit now. So yeah, yes, let's talk about polynomial in just a few minutes. So changing of subject of the formula is very easy. Just follow it step by step, then you will actually make anything the subject of formula. So just know that anytime you're having square roots, cube roots, is just simply by changing it to the other side. Or so once you know that, then you are good to go with this. So the best way to actually get better in math is actually to practice. All right, now let's talk about polynomial also a bit. So under polynomial, we have what we call a factor theorem, and also we have a remainder theorem. Polynomial. All right. So now in polynomial, you know, if you have maybe we have a degree, we can have a degree 1, of course, it's also a polynomial. We can have degree 2, we can have degree 3, we can have degree 4, and so on like that. Degree 2 is what we reverse to as quadratic. Do you get? So now let's see how we can do this. Let's generalize it first. Let's see polynomial equation now. Let's say ax raised to power z, bit like that. Yeah, it's also fine. The next one can be ax raised to power 1 plus ax raised to power 2, ax raised to power 3. We cannot use a or through. We can't use a or through. Not. So a1 x1, we can use a2x2, a3x3 plus a4x raised to power 4, and so on. So what we have here is actually a series in which our polynomial equation follows. So for every polynomial, it actually will be this. Do you get? No. Now, if I want to form any polynomial from here, I can easily form it. This means first term, second term, third term, and so on like that. So if I have this now, I can say, okay, if I have x plus x raised to power 4, x raised to power 3, we can turn it off in the other way also is the same thing. So x raised to power 2 plus maybe plus 4 is equal to, this is a polynomial equation. How is it a polynomial equation? You can see that we can start from the highest one. Of course, they used to do a raised to power n, a raised to power n minus 1, a raised to power n minus 2, and so on. It's still the same thing with what I wrote here. You can just write in it in ascending order or write it in descending order. So now, if I have something like this, it also means polynomial. But the polynomial that JAMB will actually ask, they will not ask more than the one that have the 3, the degree 3. That is the highest one they can actually ask. So now, what do you mean by a factor? What do you mean by a remainder? Now, let's take for instance, what do you mean by a factor? Let's firstly talk about the factor first. So let's see, if I have like s squared now, which is a example of polynomial. Let's take for instance, we have s squared plus 5s plus 6 now is equal to 0. So if I try to factorize this, s squared plus 5s plus 6 is equal to 0 now. If I try to factorize it, how can I factorize this? I can easily use my this method. What will I multiply? And I'll have this. I can have 3 and what? 3 and 2. 3 times 2, 6. 3 plus 2, 5. So I can say this guy is simply s squared plus 3s plus 2x plus 6 is equal to 0. This is not our main subject. That's why I'm trying to rush this one. All right. So now, if I have this now, you can easily factorize x into bracket s plus what? S plus 3. Then this one